All right, so in this question, you're given five straight lines, and you are asked to find the equation of each line. Y equals mx plus c. You can use any method. You could use table method, you could use gradient intercept method, starting from question A, then B, then C, D, and then E. All right, so let's have a look at A. What do we have? What information do we have for A? A is sloping towards the left, so we can see that the gradient is going to be negative. All right, and we can also see that the gradient will be rise over run. So I can go up, that's 3 units, and I can go right, which is 3 units. And so that will be that's 4 units. That'll be 4 over 3, and that'll be your gradient. So this is going to be an m value of 4 over 3, and a c value, which is your y-intercept over there, equal to negative 3. Remember, we need to get y equals mx plus c, and so therefore the answer for A will be y equals to 4 over 3 x minus 3. For B, let's see what information do we have for B. For B, we have a point over here, which is 8 and 4. 8 down, 4 that way. And this is the point 0, 0. And so that over there is going to be 4. And this over here is going to be 8. So the gradient for this line is going to be, let's just write that down again. It's going to be 4, and this is going to be 8. So it'll be 4 over 8 for this line. So it'll be 4 over 8 simplified to a half. The y-intercept is the x and y axis intercept, which is 0, 0. So the y-intercept is 0, 0, which means that c will equal 0 for this line. Y equals mx plus c, half x plus 0. But we don't put the 0 in, so just half x. Any line that goes through the center of the Cartesian plane will not have a c value, because c is equal to 0, which is your y-intercept. Your y-intercept equals 0. So we don't need it. We just need the gradient for this particular line. All right, B done. Let's have a look at C. C is a vertical line that is running through 8. I should have put in 90 degrees over there and a 90 degrees over there as well. All right, so this is a vertical line running through 8. Then this is not going to have any gradient, all right, or y-intercept. This is simply a vertical line where 8 is the x value that's not changing all the way through. All right, 8 is going to be the same x value on this line everywhere on this line, x equals 8. So this line is simply x equals 8. It's a vertical line. All vertical lines have x equals something. All horizontal lines have y equals something. We'll see that in E now. Let's look at D first. Looking at line D, I can see 6 units as my change in y, 8 units as my change in x. So my gradient is going to be change in y over change in x, which is 6 over 8. Now, if you notice, there's actually an error over here, which is 4 over 3. If you spotted that error, well done. This should have been negative 4 over 3, because this line over here is negative. The gradient is negative, right? All right, so that's going to be negative 4 over 3, and that should have been stated over there. All right, just adapting that now. Negative 4 over 3. This line over here is positive 6 over 4, which is positive 3 over 4 simplified. Remember, change in y is going to be your rise, and your run is equal to 8. Rise over run, 6 over 4, and it's positive. So that's going to be for D, y equals to 3 over 4x. Now remember, the y-intercept for D is negative 6. C equals to negative 6 for this. So minus 6 over here. And then E is a horizontal line that's running through 2. Every single point on this line is equal to 2. That's the line. Remember, this was x equals 8. This is y equals to 2. So your answer for E, y equals to 2. And that's all the different straight lines. All right, don't forget this is supposed to be negative. Let's make a note of that. So that's negative. All right.